This is section 4.6, inverse trigonometric functions. Remember from section 1.7, we talked about inverse functions in general. And one of the requirements as to whether a function can have an inverse or not is whether it is one-to-one. And in order to be a one-to-one function, the graph of that function has to pass a horizontal line test, meaning that if an imaginary horizontal line is passed through the graph, it cannot hit the graph more than once. Well, all of our trig functions are periodic, which means that none of them will pass the horizontal line test as written. Okay, just a general sine function does not have an inverse. But it is useful to be able to reverse these things. So what we do is we restrict the domain on our trig functions. So if we here on this example, if we have our sine graph, they restrict the domain so in a location near 0 so that the graph has every y value represented between -1 and 1. So right here on this region for sine, that represents every negative value or every value from y between -1 and 1. It wouldn't make sense to do it from here to here because our y values are only positive. So basically, that's the consideration. Restrict the domain near 0 so that it's easy to deal with, and you have every y value represented. Okay? So if we do this, then what we have here is read y equals sine inverse. Sine inverse is also called arcsine. You're not going to see this quite as often, but it is the same thing. This is not 1 over sine. This is not equal to cosecant. It's the inverse of sine. It's like remembering the difference between 1 over f and f minus 1 when we're talking about function notation. Okay? Remember that domain and range are switched between inverse functions. So the range of sine is -1 to 1, so that is the domain of inverse sine. Now, we had to restrict the domain here between -π/2 to π/2, so that is the range of of answers to inverse sine. Okay? Now, basically what we have here is the chart that goes along with sine, except it's reversed. Okay? With normal sine, if you'd take sine of -π/2 and your answer would be 1. This is saying if you have -1 and you find inverse sine of it, you're going to get -π/2 back. Okay? Now, the important thing to remember is that we're going to be using these things to reverse, and perhaps I will actually need the answer that goes along with 3π/2, or I might need to be in a different quadrant or whatever when I'm talking about the unit circle. But I'll only get answers back in here. So that means that we're going to have to be aware of what we're being asked to do, and we might need to make some adjustments. Okay? If you plot your sine graph right here, which is in blue, which is this, except the x-axis is stretched out a little bit, so it's a little bit flatter. Inverse functions are symmetric about the line y equal to x, and so this is basically what our inverse sine function looks like. Just notice your x and your y values are switched around here. Okay, so let's look at some of these problems. Let's find the exact value of y or state that y is undefined. Okay, now I'm going to show the unit circle here. The domain, the domain is between, the range of our inverse sine is between -π/2 to π/2. We will only get answers over here. And what's more, you will never give an answer of 11π/6 because it needs to be the negative version of that. So if you end up getting an answer that's here, you're going to have to write that as -π/6, not 11π/6. That's what I mean by making the adjustments necessary. We have y equal to sine inverse of -1/2. Now that's asking us what angle gives us a sine value of -1/2. So if we look here, negative 1/2 in these two quadrants of the unit circle. Negative 1/2 happens at 11 pi over 6. And like I said, you need to give the negative version of these angles. So this is negative pi over 6. Okay. Now, if I do the same thing here, I want to find the angle that gives a sine value of negative square root 2 over 2. And it needs to be in these two quadrants. Negative square root 2 over 2 is here, which is 7 pi over 4, which we need the negative version of, so that's negative pi over 4. Okay. Now, sine inverse of the square root of 3. Okay. Square root of 3 for sine, that's not anywhere on here. And what's more is the square root of 3 is larger than 1. Okay? The domain of the inverse sine is between negative 1 and 1. This is too large. This is undefined. And that's because the square root of 3 is larger than 1. So it doesn't have an inverse sine. Okay? Now, similar, the inverse cosine function. And again, we still have to restrict the domain of it because it is periodic, and we still want to make sure that we have every value represented between negative 1 and 1. And because of where the cosine function is located, I can't use the same restriction because I would have only positive values. So cosine is restricted between 0 and pi. And when it comes to the unit circle, that means inverse cosine is going to give us solutions here and here, not here and here. That's because cosine is positive on both of these, and that doesn't do us any good. So it's quadrant 1 and quadrant 2 for cosine. Everything is restricted the same way. You have the same sort of chart that we had for inverse sine. And then you have your graph that will look something like this. This is your cosine function right in that area. And then you reflect over y equal x to get the graph of inverse cosine. Okay, so let's do the same type of thing. Find the exact value of y or state that y is undefined. So where is cosine equal to negative square root 3 over 2? For inverse cosine, we look in quadrants 1 or 2. Negative square root 3 over 2 is right here, which is 5 pi over 6. And here and here, we've actually restricted it on the positive. Sorry, get it on the screen, positive right here. So we don't have to worry about using the negative versions of these angles. So our answer right here is 5 pi over 6. Okay. All right. What is arc cosine, which is inverse cosine of negative 1? Well, where is cosine equal to negative 1? Over here at pi. Okay. And inverse cosine of negative 2? Well, we can only get answers from regular cosine between negative 1 and 1, so this is undefined. Because negative 2 is smaller than negative 1, and therefore it is not in our domain.